Right. Welcome everyone to Recipes for API Ninja. My name is Sandip Dhummad. I'm an enterprise architect at S&P Global Ratings.
And myself, Amit Patel.
Um, I lead basically a DevSecOps communities of practice in S&P Global Ratings, being part of Enterprise Architecture Group, and Amit presents the API communities of practice. With that, here is the agenda. So what we're going to talk about today is we're going to take a look at some of the API best practices that you may want to follow in your API design. And then in the end, we're going to do a live demo. So now it's confirmed that this is very popular graph, right? So anyway, so what we want to talk about is that there are over 19,000 APIs already out there as of January 2018. And every year, there are about 2,000 APIs getting added. So the questions that every business is asking themselves is that, what is there in API? How important is this APIs for driving their growth? And there was a very interesting article back in 2015 in Harvard Business Review. And what they talked about is that there are two strategic business benefits of implementing an API. And the number one is that API can attract blockbuster compliments. So what do they mean by that is that I think we looked at that numbers as well. Like Priceline back in 2015 had 80% of their revenue coming from their API, not from their website. And for Salesforce, it was 50%. The second strategic benefit that they talked about is that APIs are the windows for the new ecosystem. So what do we mean by that? So one example, you got products and services. And if you start exposing your products and services as an API, now what you just did is that you converted your products and services as a platform. So now people can come in, start building the applications of their interest using your data, and then this will basically a new window of opportunity for you to learn, understand that what is the value of your data. And this very important example of that is IBM. When they built the Watson system, they did not build an engineered system out of Watson. Rather, they made Watson available as a public API, as a platform to the people so that they can try, explore. And then now they are learning that how people can think of using a cognitive system like IBM Watson for their benefit. So it's really an window to the new ecosystem, your new revenue growth opportunities. So what does that mean? So basically, because of the importance of the APIs, everybody is like pushing towards being an API first company. Now, in that journey of API first company, what happens, right? CEO, CTO comes, they say, okay, we want to become an API first company. And then somebody from architecture group will say that, so we need to define an API strategy. As soon as we start talking about an API strategy, we had gone through this journey. You get stuck into the discussions about how my microservices should be. Or you would talk about, whether I should be deploying my service on Tomcat, or I should be deploying on Docker containers, or is Netflix stack is cool, I should be going for API gateway, or I should be going for service mesh. There are whole different things. These are all very important aspects, by the way. But these are all helpful for building scalable, reliable, lightweight API, and that's it. But the big but over here is, will it make your API hit in market? Remember, there are 2,000 APIs getting added every year. So you will be lost in that crowd. So the question is that, will it make your API hit in market like Netflix API, Facebook APIs, and whatsoever? What makes your API consumer friendly? What makes your API likable to the people? Well, the API tools and technologies, they play a very important role. But at the same time, API design is also equally important. When you define an API, you want to pay more attention to your API designs as well. Now, to make it more fun, so what we did was, we tried to use an analogy of cooking to a RESTful API development. So take a look at this picture, right? So you got, let's say, you got set of customers coming to you, providing different kinds of requirements, vegan, lacto-vegetarian, and whatnot. Now, you as a cook, your challenge is to cook a recipe according to their taste. Now, the quality of that recipe really depends on who is cooking it. Like, for an example, if somebody like me, who is a regular cook, who is just an hobbyist, and try to build this recipe, maybe the quality of that API will not be that great, versus somebody who is professional, who is chef, and if he is building the API, he is building this recipe, probably your customer is going to like it. So with that, what we are going to say here is that if you as an API ninja, if you focus on certain API capabilities that you need to have ground up as your API foundation, then that will basically help you build the API which are comprehensive, and then people would potentially like your APIs. So with that, recipe number 1, building RESTful services. Now everybody will think that, what's big deal? It's trivial. I get one class or method, I put an annotation on that class, it becomes a RESTful API. Well, that's true. Building an API is very trivial. But remember, there are some design aspects of your API which are very important, even though they sound very small. Let's start with URI. URI is like an identity of your API. It's like somebody's name. You want to pay a lot of attention to what is your URI going to be for the API that you are building here. And there are 4 different archetypes. Generally, people come with a variety of different patterns for building the URI. But when you think about the URIs, right, there are 4 different resource archetypes which are available. One of those is, when you say that /customer/John, what's gonna happen? What should happen is it should return a document with set of fields, and fields are assigned to a values or the links. So that's your document archetype. If you say /customers, it should return you a collection of the documents, which is your collection archetype. If you say, okay, I want to update John's information, then you say that, I'm going to put a put request with an URI called /customer/John, and then so these are the 3 different archetypes. The 4th one, which is very powerful, called controller. Where do you use it? Like, there are some business functions, like you want to do a credit check of the customer. Now, this is a business functionality that you want to implement. This cannot be mapped to any of these 3 things that we talked about. Then what does that mean? That means that it requires its own URI, its own endpoint, and that's the controller archetype. Generally, you could map all other 3 archetypes as a controller archetype. Technically you could do it. But the problem with that is, you would end up in creating so many API endpoints, and you would end up in the issues of service sprawl, and that's difficult for consumer because now your APIs are becoming non-intuitive. Regarding action mapping, just follow these standard risk conventions. Moving on. So naming conventions, very important. Define a standard. Whatever is your standard? Take an example of URI. I would start with all lowercase. If I have multi-word phrase, I would separate them by hyphen, not with underscore. Underscores are difficult to type. So these are the things you may want to take care. API documentation, the last but not least. The adoption of your API, remember what we are talking about, making your API likable. Adoption of your API really depends on API documentation. Now, when we talk about API documentation, it's not a bunch of Word documents. We are talking about a live document where somebody, like consumer, come in, they try out your API with the test data, and they get a feel of your API. That's your API documentation. So never ever neglect the API documentation. The recipe number 2, input data validation. There are 3 points I want to talk here. It's pretty straightforward. Make sure that you use cross-cutting aspects for building the API input data validation. Leverage some consistent error handling mechanism across all the APIs, right? So you are not creating any confusions to your consumers. And then make sure that you sanitize your data before you process within your API. That will help you avoid a lot of security attacks. With that, let's move on to the taco. So your business user who gave you a requirement of building customer API, you build the customer API, everybody likes it. Now he comes back and says, hey, by the way, we are thinking of launching an Android app, and can you provide us an API? So you have 2 choices. Give your API as is. The problem with that is, you would be returning so many fields which is not required. It's overpatching problem. So you got multiple approaches here. So number 1 approach for solving this problem called controller resource. We talked about controller resource. It's a very handy tool. So what you do is you define an API endpoint called /customer/light slash customers slash one slash light. What is that? What's that gonna do is, you would have those field filter mechanism implemented right in your service implementation, and you return only the fields that is required for the Android application. We had seen some people. This is one of the simplest implementation that generally people would go about it to start with. We have seen some people, they use versioning, like version 1 for web, version 2 for mobile. Never ever use it. Versioning are not meant for this purpose. The third approach is that what you could do is, third, which is like kind of nicer approach called identifying path. So what you do is, in the beginning of your URI, you could provide this meta information. It's called an identifying path. Like for an example, you say /mobile /customer /1. That's your URI. So your API understands that, okay, this API endpoint is for the mobile form factor, so I would be returning the results based on the mobile application need, like Android application need. You could also implement some other dimensions, not only the form factor. You could try out something like, the client types, product types, package types. Like there is one example here. You say /premium /customer /1, meaning that now because this guy is your premium customers, you may want to provide more data information compared to the regular ones. So this is the approach. All three approaches that we talked about so far, they lead to one problem. They lead to many problems. They lead to overpatching, underpatching, service sprawl problems, and these are all server-side implementation. But if you think about it, who is the best judge of the shape of the data? Consumer. They know that what they are looking for. What if you provide some kind of ability to a consumer where they come in and they say, hey, by the way, I'm interested in these 4 fields. Can you please help me give those 4 fields? I, as a service provider, I have all right to define my domain object. I say that these are the 20 fields that I would be returning. But the consumer comes and says, hey, I need only 4 fields. That's like a win-win situation for both of them. If you get this ability implemented as part of your API framework, your APIs, your consumers are gonna like it. It's like win-win situation. You don't run into the problems of overpatching, underpatching, service, the service sprawl, version sprawl, etc. And that will make your API pretty good. So anyway, so now your business user comes back again. This says, hey, so we launched the web application, we launched the Android application, everything looks good. What if I want to build a marketing campaign and I want to see only New York City customers because I'm from New York? So the solution that you have is that you go in and then you leverage the controller resource and build a new API for returning the New York City customers. This is like server-side filtering. This is like pretty common, simplest implementation that you would see out there. But if you think about it again, the biggest problem with this is that there is so much you could do. The current example talks about the exact match, like city equals NYC. But what if your same user comes back and says, hey, I want the customers of New York City and Austin? Then what you're gonna do? So what you did is just now introduce one more aspect called logical operators. And same way, if you think about it, you would need to support relational operators, you need to support like queries and whatnot. So what we are looking for is some kind of SQL-like light querying mechanism that consumers can have it handy, and then they can filter the data however they want. If you provide this feature to consumer, they're gonna love it because they can play with your data and your API becomes more versatile to them. But it sounds promising to go after it, but the word of caution, the inner architecture of implementing this thing is very complicated. So make sure that whatever path you choose, please use some kind of open specification or de facto standards for implementing that, because there will be some open source implementations out there. They can help you provide the great starting point. So with that, I think I would invite my colleague to go over the other recipes.
Thanks, Sandip. Can you guys hear me? I think so. Okay, cool. So now we know about the recipes for Ninja, and we know how to avoid underfetching, overfetching, avoid version sprawl and service sprawl. We should be good, right? Our API should be rock solid. Well, just then the customer came complaining. Why is the API is not performing very well, and why are you returning me everything like huge payload? So remember, the performance and reliability of your API is a very important aspect of keeping your customer happy and keeping your customer like your API. So what can we do about it? One area of we can explore is the pagination. Well, most of you must be using pagination. There are many options. You can do client-side pagination, server-side pagination, or even you can do the database-side pagination. Let's just focus on the server-side pagination, right? The most common and simplest approach for pagination is the offset pagination, where you have your API accept the query parameters limit and offset, and that will allow your client to iterate through the collection on the server side, right? Pretty good. But sometimes this offset pagination can also result in performance hit, and especially when your underlying data is constantly changing, you might see weird results for the offset pagination. The other new approach, which is getting quite popular, is called the continuation token approach. What we do here is you introduce a new block in your response. Let's say, for example, links. It's kind of Hatios style API. In links, you provide the link to the next page, like how the client can get the next page. And this next page has a continuation token provided by the server. This continuation token is pointing to the last result in the page that client is looking at. And when they when they make the request to the next page, this token goes back to server, and server knows exactly what you have seen so far and what should be the next item that should be returned to you, right? So consider using pagination whenever you have multiple results. You are returning a collection of items in the response. Well, the performance is still low. So sometimes database and slow SQL queries can be the bottleneck, right? And it's hard to scale the database with the needs of your APIs. So in that case, consider using caching for the read-only APIs. So there are many caching options available. What you can do is make sure the API application is correctly using the cache control headers for HTTP. That will force your response to be cached on the client side. And also for server side, you can use the distributed caches like Memcache or Redis. And the last option that you can you also need to be aware of is the compression. Like sometimes your object might be huge, so even after doing all these things, you are generating a huge payload. So for that, there are tons of popular algorithms available for compression out there in the market. Just pick wisely. Pick the one which is widely supported by all your clients, and compression will allow to reduce the network bandwidth by 50% sometimes, and it will make your APIs faster. All right, so with that said, enough talking. We have time. Good. So we're just gonna do a quick demo of what we talked about. So we have the application. As you can see, I have the customer's API, which is returning me the 4 customers. One of the company name is Docker, Amazon, Apple, and Dropbox. What if I just want to get the company name starting with letter D? Well, so as you can see, we are not introducing a new API. We are just giving the control to the client so they can query your API. All right, this is good, but this is still returning too many fields. I'm only interested in the company name and the primary email, let's say. Well, no problem. As you can see, the full underlying implementation is the same. You are still having just one endpoint, and the client is the one deciding how and what information they want to get back in the response. So I think that's all we have. Yep. Thank you, guys.